big stop here. You see that? Do not round in this unit. Do not round in this unit. It's 3 decimals, 4 decimals, you name it. You just use them all. And you'll see why I mentioned this, because we won't have to round. That's the key here. So let's get started. So if you have a highlighter or two, I will use highlighters. And at first you just have to trust me. Right now you just have to trust me and go along for the ride. And then as we go along for the ride, I'm going to try to make you understand the concept. Okay? All right. Page 2. Accuracy refers to how close a measurement is to its target value. So accuracy, I'm going to define it in multiple ways, not just one way, but one of them is it refers to how close the measurement is to the actual target value. To be accurate, a measured value must be as close to the real value as possible. Okay, so I'm going to highlight that part. To be accurate, a measured value must be as close to the real value. Okay. If you claim to have measured something accurately, someone should be able to repeat, so here it is, repeat the process and get the same value. So if I grab this marker, right, and I want to know the diameter of the marker, I'm going to grab this tool. Anybody know what this is called? It starts with a C. A caliper. I don't know if you've heard of that before, but somebody should go, the screen is dead because I'm out of batteries, but somebody should be able to grab this and say 0.75 of an inch, 3/4 of an inch. I give it to Caleb. He should be able to go in 3/4 of an inch, right? We should be able to repeat it over and over. Then we would say a measurement is accurate. And this is how, like, how would you achieve that? How to get accuracy. There's just a little note here for you. How to get accuracy. You have to use a standard unit. What is a standard unit? Some examples here, right here next to you. Centimeters, inches, kilometers, miles, kilograms, milliliters. Around the world, people would know what this is. The cups, teaspoons, tablespoons, those are all standard units. British use stones to measure weight. Did you know that? It's like an actual measurement. So I'm 35 stones, right? Like, sounds weird, but it's actually a standard measurement. Nobody uses it, but there's a standard for it. And use an appropriate scale. Okay, so if these two things, if you can ensure that these two things happen, you will be able to repeat the process of measuring and most likely get the same value. So these two things allow you to, so these go hand in hand. Okay, these go hand in hand. Non-standard units, any body part, right? So hand span, using your feet. And you might think, right, like feet, my foot is going to be a lot bigger than some of your feet. I can guarantee you that, right? So it's not accurate, it's not standard. So if I measure the width of this room, I might say 20 steps, and some of you might say 25 steps. Can't repeat it, right? Like, it's not accurate. So it's not standard, and it's not, you can't repeat the measurement. So let's keep going here. Accuracy can be affected by two things: improper or careless use of the measuring device. So that would be regarding the usage of it, and this would be a second option, could be a damaged or faulty measuring device. Sometimes the device itself can be the problem. And here are some examples, one of each. So if you look at these pictures here, when you look at usage, this person is leveling off the flour, right? So you measure a cup and then leveling off. That's good, right? What's wrong with this one? Hasn't leveled off the top, right? So I will say this one would be not accurate due to improper use of device. So technically the cup is a measuring device, right? So you might say it needs to be leveled off. It needs to be leveled off. Another example of faulty, right? Faulty or damaged measuring device. It was hard to find something that would look. So this is a nice flat, right? Ruler, straight. You go over to this side and you see that it has a bit of a bend to it. So I don't know if you remember your elementary or junior high years, right? Those rulers that are all flimsy. Some students would do all kinds of stuff with it, right? You're actually messing with accuracy now, because you might think it's not a big deal, but for us in this course, it would affect your accuracy, okay? Because now it's not the same. That 30 centimeters is technically not 30 centimeters anymore. I have one there, but I don't want to break it, so I'm just going to leave it. So damaged or faulty ruler, therefore not accurate. So that can affect accuracy, as well as the scale and the units that have been used. So if the province or myself ever tell you a bit of a story, should have been this, but got this, what could have affected it? Make a note to either how it was used or that it may have been faulty. How so, right? A ruler was bent maybe. Or when you're doing the cups, sometimes you measure milk and then flour. Some of the flour is going to be caked on, right? Stick on the cup. So technically that's for us considered improper use of the measuring device. Because if you measure up 4 cups, you're not going to quite have 4 cups of it on there. And you're like, big deal, the cake is still going to turn out all right. I agree with you. I wouldn't disagree, but I have to be specific for this course, okay? Now, I'm going to do one example, and then I'm going to ask you to do the rest on this page. So, something happened, and we're going to determine whether or not we would consider that measurement accurate. So state whether or not each scenario would result in accurate measurement. Explain making reference to the unit being used and the scale. So you're going to talk about the unit and the scale, both of those items. So watch carefully. So the first scenario is using centimeters to measure someone's height. And first thing I would note is like, hey, that is a standard unit, right? Standard unit, check. Centimeters are universally known. Centimeters to measure height, is that an appropriate scale? I would say so. Yeah, scale is appropriate. Let's talk about what else would be appropriate. I'm just going to put a check mark there. You're saying it passes this and it passes the scale test. You could use feet, inches, meters. That's about it. Right? If once you start using kilometers and miles, yards wouldn't be the best for the height of a person, right? So that's not appropriate. So once you say check, check, you can say therefore accurate. Therefore, we conclude that this particular case is accurate. So as soon as there is an X somewhere, if it doesn't pass the test, you can actually just skip to saying it's not appropriate, not accurate, not accurate. Okay, but I will actually, when I go over it with you, I'm gonna always comment on both items for every single one, just so you see how that works. So I want you to read those, and there's one on the other side, F. Try that one as well. And if you get it wrong, big deal. Today it's not a big deal. Just try to figure out each of the scenarios if it's accurate or not. Go to town. Let's see how you did. Forearm to measure a picnic table. Not standard. Therefore, right, it doesn't pass that test. You can actually say not accurate, but I would say scale is appropriate. It's not outrageous to measure the width of a picnic table using your forearm, right? It's not crazy to think, right? Like it actually, the scale is good, but it's still not accurate. Using a meter stick to measure the distance between two cities. Standard. It's a meter, right? So that's good, but the scale is not good. Not appropriate. Scale. Right? So it's still not accurate. And some of you will press me on this. What if the cities are right beside each other? Yeah, I get it. You would get me on that one. I would have to be more specific, right? But most of the time, cities are kilometers, hundreds of kilometers apart, right? Using a ruler marked in millimeters to measure the width of a textbook. Millimeters is your standard unit. And the width of a textbook, what do you think? It's not unheard of, right? I would probably use centimeters, but millimeters is fine, right? Appropriate scale, therefore accurate. Oh, I don't know if I mentioned 3 dots means therefore in math. Don't use it in English, it won't go very well for you. Use your stride or your step to measure a volleyball court, not standard. Right. What's that? No, they mean stride or step, but even if it is your actual foot, it would still not be good. If they mean like foot as a measurement, using feet, that'd be different, but using your foot, no. So not standard. Volleyball court, is that all right? So users, I would measure if I had to play just like that, I would just steps, right? So it is appropriate. I can tell already you love it. You love this unit. That's okay. So it's not accurate. What's all this mumble jumble, right, about accuracy, not accuracy, right? So there you go. For us specifically, in these cases, we would look at those two things. So for your study sheet, I would say this. I'm going back just quickly here. I would say to be accurate, the units have to be standard, the scale has to be appropriate. But accuracy can, so these two have to happen so that you can repeat the measurement and get the same value. But it can also be affected by one of these. Like you could have a standard unit and a good scale, but not use it properly, right? The measurement, like the device could not be used properly, or it may be damaged. Then that's a different story. So it all goes in the same bag though. It's all connected in a sense. Okay. I will ask you specifically, is this accurate? And then you read the story, you should be able to tell what's happening, right? Oh yeah, I'm going to talk about unit and I'm going to talk about the scale. One more. Tablespoon to measure the sugar required for a cake. This is standard unit. and scale is appropriate. Therefore, accurate. Done. I could do sentences, but I figured you'd rather not have sentences. Okay. Here's a different story, right? So Mary used a measuring tape to determine the width of a wood piece. It was supposed to be 4 inches wide, yet she recorded 3 7/8. Why might this be? Explain using your knowledge of accuracy. So note that we're talking inches, so that's a standard unit, and it's also a good scale. So in that sense, there's no issue there. So you need to pick the other two. So maybe I'll say that for you because you're new to this. So I'll say, notice that a standard unit, this is on page 4, standard unit is being used, and that the scale is appropriate. So you have nothing to say in that regard. It would be accurate, but something is off, right? You're still saying you're off here. So you can say improper use, right? Maybe talk about that. She may not have, right, ensured that the tape is straight and flat. Oop, what happened there? It's flat. So if you didn't make sure the tape is like flat on the piece of wood, straight up, right, like completely straight, then that may have affected it. That's why she's off. Right? Or you can say damaged tape, right? Some markings may have been scratched off. I don't know if you've ever used measuring tapes for a while, but once you use them for a while, they start to blur off, like those markings start to come off. Some of the numbers even come off. So it's time to get a new one, right? So that, in this case, that's what I would talk about. And the other one was the cup with flour, right? Did the baker level off the cup? Did you use something else beforehand? Try to put yourself in that scenario and see what could have happened, right? Okay. Let's keep going. So we're going to switch gears here. Okay. Switch gears. And I'm gonna pass it back and forth. I'm gonna do one, and I'll ask you to do one, and it's gonna go back and forth like that. Okay. So this is on page 5. So we talked about accuracy. Now we're going to talk about precision and uncertainty. Here we go. Precision refers to the smallest increment on a measuring device. The smallest increment on a measuring device. That's what precision is. Right? What are you talking about? So maybe look at, I was going to use this thermometer here, but it's super small. Let's try to, anybody taking chemistry, right? Or even just science? I'm sure you use thermometers all the time. There we go. So this is upside down, sorry. There. In this particular case, this one is set to Fahrenheit. So what's the smallest increment for this measuring device? How much are we going up by every marking? We're going up 1 degree Fahrenheit, right? Sorry, this looks, It may look like a ruler, but this is actually a thermometer. Yeah, it's a thermometer and it's set to Fahrenheit. No, Celsius. Sorry, my bad, Celsius. So, you know what? If it had been a ruler, 1 millimeter would have been correct. In this case, Celsius. So this one goes up by 1 degree Celsius every single time. So we would say the precision of this thing is 1 degree Celsius, right? So keep that in mind. I have to make sure I don't break it because the science folks would not be happy with me. I borrowed it. Okay, so let's keep going. And tomorrow I'm going to bring a whole bunch of gadgets to make the point even clearer. Another way of saying this is that precision, here it is. Another way of saying it, the exact same thing is precision is the smallest amount by which a measuring device can go up or down by. Think about it that way. It's the smallest amount a measuring device can go up or down by. Every measuring device, guys, you don't know it, you don't think of it, but I'm telling you, every measuring device, no matter how precise, will have a limitation. There will be a limit to what it can do. Precision essentially states what the limitation is. There's a precision essentially states what the limitation is. So all three sentences here are exactly the same. They're saying the same thing, just in a different way. Okay. I also borrowed a scale from the, I'll bring my own tomorrow, but I didn't think of it this morning. So pay attention to this one. I'm going to try my best to illustrate this. Let's see here. You can't really see the numbers, so I'm going to have to do some magic with the camera here. Let's see. There we go. Can you see that? 0, 0? Yeah. Okay, so let's take this pencil, for example, and just weigh it. And you're like, okay, 5.62 grams. I tried my best to make something that's worth 0.001 of a gram. So my goal with this is to get the 2 back here to turn to a 3. Okay, so let's see. I'm going to put that sticky note that ripped off. Not quite. Oh, there you go. Did you see that jump to 63? So this device is precise down to the second decimal here. It's precise to 0.01 of a gram. Because let's say I make it a little heavier, so I'm going to put a little bit more of sticky notes on there. I hope this works. I really do. Yeah, there we go. Now went up by 0.01 again. So this thing is, that's the limitation, 0.01 of a gram. But let me ask you this. Do you think there would be more decimals past the 3? Like, do you think in reality this thing could be like in between 6.3 and 6.2? Do you think it could be? And in fact, it is. It could be between 5.62 and 5.63, but the thing rounds at some point because it can't do more than that. Does that make sense? It rounds, guys. So let's use a thermometer, for example, the one in my room back there. Maybe don't copy it right now, but my thermometer back there is set to 72 degrees Fahrenheit. That's what it says on the screen. And the air conditioner is going to keep going until it reaches that temperature. However, we don't know if it's perhaps in this room 72.3, 72.4, right? We don't know. Like, that thing is limited just to the nearest degree, right? So the limitation of this, I'll just tell you that the precision of, if you saw this 72 degrees Fahrenheit, you would say that precision is 1 degree Fahrenheit. And let's talk about the uncertainty. I'm just going to go U there. Let's talk about uncertainty and then we'll fill this in. We're not ready yet. I was kind of jumping too far here. I'm going to use a different highlighter for uncertainty because I don't want to mix them up. So here's your uncertainty. Due to the fact that every measuring device has a certain limitation, there's always some uncertainty, right? There's always going to be some unknown, right, part to a measurement. All measurements have the potential to be off, right? Measurements have the potential to be off, regardless of the precision of the measuring device. At some point, right, at some point you round either up or down. The device does. You don't see it, but the device does round up or down at some point. And this is a fancy word for uncertainty is margin of error. They mean the same thing. Margin of error, like how much you can be off by. Like it's the window that we can be off by. And here is another important statement. Uncertainty is always half of what we determine the precision to be. In general, unless otherwise stated. Right? I have to just put that in there just in case. And so box this in and make sure this goes on your study sheet. It's one of the few formulas you're going to have here. But uncertainty is always found by taking a precision and dividing it by 2. And notice what it says here, usually stated with a plus or minus. It doesn't have to be. The province is okay if you don't. But if precision is 1 Fahrenheit for us here, then uncertainty is 1 degree Fahrenheit divided by 2, which is plus or minus 0.5 degrees Fahrenheit. So we technically can say this room is at 72 degrees Fahrenheit, maybe half a degree above it or half a degree below it. We don't know, we're not quite sure. But we are assuming that this is going to be the case. Let's do some variations of this. So as many years as I've taught this, I think I can go back 10 years that I taught this course. Some changes have been made, but these are the 3 scenarios you're going to encounter on the exam. They might give you a picture, they might just give you a number, or they will say what the precision is in words. So you have to kind of figure out, right, what the precision and the uncertainty is given the following. So it could be this scenario, it could be this scenario, it could be that scenario. We don't know. I cannot tell you what you're going to get. But I can prepare you for either one or any one of those. So here we go, guys. Ready? Precision. When you look at this, you should look at milliliters, so you know the units. And all you have is numbers. So how much are you going up by every time? You should see that it's 10 milliliters, right? Up or down, by the way. But I'm just going to go plus 10. So the smallest increment from one number to another is 10. Therefore, go ahead, my precision is 10. Device, I'm going to zoom into that corner there, just for now. There, that way you don't have to squint. Okay. Device goes up or down by 10 milliliters, the smallest increment we can tell. Okay. So now we can say precision is going to be 10 milliliters. And the uncertainty, so that's the beauty of this. Let's say you get your precision wrong. You messed it up, you got a wrong answer. If you show that you're taking your precision and dividing it in half, you still get partial marks. Okay, guys? So that's plus or minus. 10 divided by 2 is 5, right? 5 mLs. So this is what you get graded on this particular question. They may just ask for precision. They may ask for precision and uncertainty. But remember, you need your precision to figure out your uncertainty, regardless of how you do it. So here we have precision and uncertainty, boom, right? That's a picture. Let's go to the actual measurement. We have no idea what measuring device was used. Was it digital? Was a person just going with a ruler? We don't know. We don't know. So all we have is we have the number. So what we'll say is, I will make a note here. That is where the precision is at. It's on that last digit where the action happens. And let me tell you what you should be thinking of. Think of it this way. On the device, you measured that, right? That's what you ended up measuring. But if this were a little bit longer, if this piece was a little bit longer, what would the next possibility be? 28. If this piece was a little bit shorter, 55, 26, right? Think of it, think of the action that's happening here. So to go from here to here, it was plus 0.01. To go from here to here is minus 0.01. Think of it that way. It's happening on that second decimal, right? Count. There's your decimal is like 1, 2. So we have 2 decimals here as well. So my precision, in this case, I will assume is 0.01 of a centimeter. And it all goes back to the actual number. And you're like, why not 0.07, Mr. Dirksen? This thing is not going up by 0.07. That's just the number you ended up reading. But this is actually going up by 0.01 of a centimeter, or down for that matter. I know you're loving it, I know. That's okay, guys. Just follow me for now. Just stay in the game. I will help you out because I know this is a little dry. Just stay in there, okay? So you take that, grab your calculator. Oh yeah, I noticed calculator issues with this unit. If you're using one of my calculators, you will have some problems here. Let me see if I can replicate that. You should probably grab one just to make sure if you don't have your own. I'm gonna try to make it be a problem here. Hold on. So if you go 0.01 divided by 2, you get a scientific notation. So the way I fix it on my calculators, if you have one of mine, I go mode 3 times. You want to go to normal, and you want to select the second normal. And there you have it. That's really what's happening there. So 0.005 is your uncertainty. And I usually do this. I put the plus or minus. Don't forget your units. Don't forget those things. The plus or minus, if you forget that, the province says it's okay. Okay? You will be all right. So we were given a diagram, then we were given a measurement, and what about if it's in words? I will tell you that this is the easiest case ever. It says a ruler is marked in what? Half-inch increments. It's telling you what the increment is, like how much it's going up or down by. So precision is half an inch. So you go 0.5 of an inch. Boom. Oh, Mr. Dixon, can I do fractions? Absolutely. I actually love fractions. Some of you had nightmares right about now, right? Fractions. But there you go. Uncertainty, you take half an inch, right? You split it in half. What do you get? 0.5 divided by 2. Some of you already know the answer. Plus or minus 0.25 of an inch. Or what is that as a fraction? I hope I'm going to do a little bit of imperial measurement ruler. Yeah, 1/4, right? I'm going to do some imperial measuring. I think you should graduate knowing your basic how to read a ruler, like inches and partial numbers as well, part of an inch. So there you have it. This is it. Precision and uncertainty, boom. Okay. So I'm going to hand it over to you. Right now, I don't care if you get it wrong. You know what the risk is right now? 0. You get it wrong, you get every single one wrong, I won't even know, right? I just want you to try. There's little nuances you want to pay attention, right? So in this case, you notice that there are markings that don't have numbers on them, right? So you got to watch out for that. So the smallest increment here is actually 50, right? If you think about it, you go from 100 to 150, then to 200, so forth. So some students can just look at it and tell, but here it is. Sometimes it gets complicated. I'll give you a formula. So precision can be found by going high minus low divided by gaps. Write this one down. I'm going to actually do this. Say what? Gaps? What? You're probably going to want to use this for the one that's underneath this one. So what I mean by that is there might be many numbers here, right? You just want to pick one, like one, and determine that to be, this is going to be my low. This number right here is going to be my high, right? Low and high numbers. And then I'm going to determine how many gaps there are in between. So you start with a low, and just go 1, 2, right? There are 2 gaps there. So watch this. Precision is high, which is 200, minus low. You got to make sure you do that top part first. In this case, we have 2 gaps. And I'm going to highlight that in pink, right? So you can tell that's what I mean with the gaps. Right? This is just free. This is for you, right? 100 divided by 2. You can tell that your precision is going to be 50 mL. So either you saw it on the graph or you use this formula to figure that out. And uncertainty is going to be whatever you determine to be your precision divided in half, plus or minus. So that's how you do those. So you would get, I usually give 1.5 marks. So 1 for the precision, half a mark for the uncertainty. Because uncertainty is actually very easy once you have determined your precision. Next, a measurement, 6 feet, 2 inches. So you focus your attention on that, right? Let's say this would have been hours, minutes, and seconds. You focus your attention on the second, right? The seconds would be the smallest increment. So the precision is just 1 inch. We're assuming that it's either going to go 6.3 or 6.1, right? Like the increment would have been 1 inch on this device. Uncertainty is 1 divided by 2, which is plus or minus 0.5 of an inch. Exciting stuff, eh? Thank you, Mr. Dirksen. This is so much fun. Why didn't you do this first? Because I wanted you to stay. Anyways, When COVID hit, they told us you can cut some stuff. This is the first unit we cut. Right? Like when first hit, we were allowed to trim it a little bit. Measuring tape with markings of a 1/4 inch. That is key of saying 1/4 inch would be 0.25, right? 1 divided by 4 is this. So my uncertainty is 0.25 divided by 2. Have you tried it? I don't know if you did, but there it is. Don't round. Don't round in this unit. I give you the disclaimer, plus or minus 0.125 inch. You will actually find, maybe let's do this experiment here. If you take any fraction, like let's say a 1/4 inch, and you divide that in half, right? You actually end up with, like whatever the denominator is, you double that, right? So 1/4 turns to be 1/8. If you divide 1/8 in half, you end up with 1/16, right? Like you keep on getting smaller and smaller, like halfway in between, because there will be 16 16ths in 1 inch, right? 16 little markings from one side to the other. So this is just a note, okay? So you double your denominator actually when you slice a fraction in half. So I need you to try this one. And hold on. There's some other stuff on the backside, but for now, just do this one. Come up with a precision and uncertainty so you're ready for tomorrow's AC, right? It's going to be about this stuff, right? So try it. This. You ready for your million dollar question? These are actually, most of these pictures are from home. Like I just went randomly, took pictures. So this is a toaster oven timer, right? So you can see that we're in minutes, right? That's important. And there are a bunch of numbers, a bunch of dots. Guys, if these don't go up consistently, it's not a good question. There's one where it could happen, but you can just pick any 2 numbers you would like. So let's say you pick this one and this one. I like to kind of have them consecutively. You could have picked one way up here and one way down here. You get the same answer. But I'm going to make this my low and this my high. And then I'm going to count how many gaps. I'm going to start here. 1, 2, 3, 4, 5. 5 gaps. 5 steps, whatever you want to call it. And so I'm going to go precision. Because I can't tell just like that, Mr. Dirksen, I'm going to use your formula. I'm going to go high minus low, right? High minus low, and then I'm going to divide it by 5 gaps. How about I use this one? Boom. Sticks out like a sore thumb. So I'm going to go 10 divided by 5, right? I get 2 what? We're in minutes, right? So now what you've told me is that I know that every single dot represents a 2-minute increment. That's the smallest that this thing shows me, right? The smallest amount that this shows me. You might be like, I'm really good, so I can do a minute, Mr. Dirksen. Watch. I can just get in between 2 of them. But for us, that doesn't work, all right? For this class, it doesn't work. Uncertainty, you take 2 minutes, divided by 2. So now we know that plus or minus a minute. So we're saying that no matter where you put that dial, you might be off by a minute. Okay. That makes sense, right? Hopefully. So here we go. Let's look at this one. 3 decimals, right? So you hone in on that last decimal right there. So you're saying, oh, okay, this thing, I messed it up there. The 8, that's where the action is at. So I'm saying at that that last place, this thing is going up by 1 unit on that last decimal. Remember your decimal place? 1/10, 100th, 1,000th, right? Remember that? You have to write it out. I don't know if you still do that. So my precision comes straight from the number, and it's always 1. But where's the 1? Where's that happening? Where's the action happening? It's right on the last digit there. So my uncertainty, you can do this, guys. You can do this. You take that, you divide it in half. Some of you know the pattern already. You're going to have a third 0 and a 5 in this case, right? 0.001 divided by 2. That's 0.0005. Now we're getting into like aerospace engine, like cylinders. Like if that thing isn't perfectly made to a certain precision, it's just not going to fit. That part is just not going to fit. And you're dealing with metal, right? Which doesn't give. So you're perhaps dealing with this, or maybe you're down to the cellular level where these small amounts actually do matter. Okay, so you have your precision, you've got your uncertainty. Okay. Last but not least, a measuring cup marked in 125 millimeter increments. That right there is your precision. So P is 125 mLs, and uncertainty is just 125 divided by 2, which is 62. Were you already done? You just waited for me? That's awesome. Way to go, guys. Do one of these. Good job. All right. That's it for today. I have more, but I'm going to just call it a day there. Watch what I'm going to tell you. No, don't do it. Don't give us homework. 8 to 14. I'm going to post everything, like everything before already as well. I just scanned my whole thing. So you just 8 to 14 is what I asked you to do, and you're like, that's a lot. Don't do every single one if you feel like you got it. But I'm throwing, watch this. Like I went around the house, I went to town. Thermometers, hot tub temperatures, you name it, rulers. Look at this, look at that. Look at that 3 decimal scale. I have that at home, right? Gauges in my shop, right? I took pictures of gauges. So you try to figure out the precision and the uncertainty, right?